Hello everyone, welcome to my channel. My name is Varsha K and I'm a student at CMR University pursuing my undergraduate studies. This video is a part of my assignment submission for the course Programming NC guided by Dr. Nagaraj Chori. In this video, I will be presenting my work related to the concepts we have learned in the course Programming NC. I hope you find it informative and well structured. Keep watching. In this assignment, I will demonstrate how to use C to solve specific problems and explain the logic behind the code. This helps us to build a strong foundation for the more advanced languages and the concepts in computer science. Okay, now let's begin.
Mm, Do you all know what is C programming? Yeah, C programming is a general purpose. It is a procedural programming language. It was developed by Dennis Ritchie in 1972 at Bell's Lab. It is known for its efficiency and low-level access to the memory. C is often used in situations where a performance and a control over the system resources are critical. C. It serves as a foundation for many modern programming languages like C++, Java, and Python. Do you know that the C is also called as a mother of the all programming languages because languages like a C++, Java, and Python are based on it. When compared to other languages, C is fast, efficient, and powerful, used for the system software, embedded system, games, and more. Why it is important? Learning C helps us to understand the basics. It helps us to understand the basics of how computer works, making it easier to learn the other languages. C gives you control over the memory and it is very fast, making it perfect for a building powerful programming language. It is still widely used for creating operating systems, games, and embedded devices. Even C gives us a deep control over our memory and our system resources. It teaches strong programming fundamentals like a logical building and memory management. Next, how C program is used. Operating system. In operating system, C is used to build a part. It's used to build a part of the operating system like Linux. In embedded system, it is used in devices like robots, cars, and smart devices. Game development. Many game engines are built with C because it is fast and efficient. Software. C is used to write programs like databases and compilers. Basic syntax of C. Every C program must start with a header file. To access the built-in function printf main function. The program must have a main function. This is where the execution of the program start. Example of a simple program. We started with the header file, next the main function. The body of the program is written inside the curly braces. Every statement in the each C must end with the semicolon. Basics concepts. Now let's learn about a variable in C programming. Variable is a name that stores data in the computer's memory. Think of it like a container. We have to think it like a container where we can keep all the values like numbers, letters, etc. We must declare a variable before using it by specifying its data type. Example here int means integer type and age which stores a variable storing an integer value of 20. Float means float salary. It means salary. It stores a decimal number. Character. Here, character stores a single character inside a single quotes. Grade. It stores a character. Now, let's talk about data types in C. Data types are used to tell the computer what kind of data we are going to store in a variable. Each variable in the C must have a data type. Example, int. Here, for storing the int is used for storing the whole numbers like 500, 20, etc. And here, float. Float is used to store the decimal numbers like 3.14, or 1.44999 more, and a character. For storing a single character like A, B, C, like these type of data types are used in C programming. Operators in C. Operators are the symbol that performs operations on variables and values. In C, there are many types of operators and they are used to manipulate data in various ways. The main types of operators in C are: first is arithmetic operation. Arithmetic operation used for basic mathematical operations like addition, subtraction, multiplication, division, and modulus. Here, the operation is used is for addition x plus y, for subtraction x minus y, and multiplication x into y, division divided by y, modulus. Modulus, it gives the remainder of a division. Take this as an example like x is equals to 10, 100 and y is equals to 20. The result we get as like x plus y is equals to 120, x minus y is equals to 80, x into y is equals to 2000, x divided by y is equals to 5, and the modulus, the remainder we get as 0. Second, the relational operators. Relational operators are used to compare the two values or expression. These operations are essential for making decisions in your program and controlling the flow. The relation operators in C are equal to. Here it compares if the two values are equal. Second is not equal to. It compares if the values are not equal. Third is less than. Checks if the left operand is less than the right operand. Here greater than. It checks the if the left operand is greater than the right operand. Less than or equal to. Check if the left operand is less than or equal to the right operand. Greater than or equal to. It checks the left operand is greater or equal to the right operand. And the third is logical operators. Logical operators are used to combine multiple conditions and return a true or false value based on the conditions provided. They are very helpful when you want to check the multiple conditions at once. There are three main logical operators in C: logical and, logical or, and logical not. Here, logical and, it returns true if both the conditions are true. Logical or, it returns true if at least one of the condition is true. Logical not, it reverses the result of a condition. If the condition is true, it becomes false, and if it's false, it becomes true. Let me take one example. Here, x is equals to 6 and y is equals to 3. X is lesser than 10 and y is greater than 1. Here we know that the value of x is 6. 6 is lesser than 10, and here 3 is greater than 1. So both the conditions are true, so it returns true. And in logical are same. X is equal to 5 and y is equal to 5. Here x is not equal to 5 and y is also not equal to 5, so it returns false because both the conditions are false. Here, here same, x is equal to y, because here in this logical, x is not equal to y, and here the x value is 6 and the y value is 3. Both the values are not equal, so it returns true. It returns true because the statement is false, so it returns true. Now let's move to the another basic concepts in C, that is control statements. Control statements in programming are used to control the flow of execution based on a certain conditions. They allow you to make decisions, repeat actions, or execute different blocks of code depending on the certain criteria. The common types of control statements are condition statement, means decision making. In that we get like if statement. If statement, it executes a block of code if only one condition is true. Let it use the executor code only if a certain condition is true. Example, if the marks is greater than 40, print f. It print like a pass. Like if the marks is lesser than 40, it doesn't print anything. If the marks is greater than 40, it print part. It just only a print the what the condition we have required, what the condition is required there. Next, if else. If else statement. It is used to execute one of the block condition. If a condition is true and the another block is if the condition is false. It is used when we have two options. Like if the condition is true, it do one thing. Otherwise, it do something else. Like we take one example, same man here. If the marks is greater than 40, it will print as pass. Else, if the marks is lesser than 40, it will print like for fail. If we take a one example like a 20 is lesser than 20 is lesser than 40. So if we type like 20, we get like a fail. And if the 40, like above 40, like 50, 60, if we put the marks as the 50 and 50, because the 50 is greater than 40, we will get the output like a for pass.
Next is if else ladder. It is used when there are the multiple conditions. It allows to test several expressions sequentially. As soon as the condition is true, it corresponding block of the code is executed and the rest are skipped. Example, here it checks the first condition. If means it checks the first condition, and else if it checks the next condition one after the another. Else here else it handles all the remaining cases when none of the above conditions are true. Example, here we just take the marks as 75. We just check on for this code. Here, if the marks is greater than or equal to 90, it will print grade A. Here, the 75 is not greater than or equal to 90, so it doesn't print as grade A. Else, if the marks is greater than or equal to 70, it prints the grade B. Here, the marks is greater than the 70, so it print it as a grade B. Here it matches to the second condition. If none of the condition matches, it print as a grade C. Now let's move to the switch statement. Switch statement is used to select one of the option from many. Let us take one example. Example here, variable day is assigned as the value of 2. Next, the switch day. It checks the value of a day against each case one by one. Here, day 2. It goes to the first statement and is checked. Here we have given like a day 2, not 1. So this block is skipped. Next, it checks for a day 3 and it matches. Day 2, it matches. So the here output we get is as a Tuesday, it is executed. Then it breaks and forces the switch to exit, so no other the cases are executed. All right. Let's dive into the looping statement, a very important topic. What are looping statements? Yeah. Looping statements allow you to execute a block of code repeatedly based on a condition. Instead of writing the same code again and again, a loop runs it automatically as long as the condition is true. Types of loop. For loop. It is used when you know in advance how many times you want to repeat something. Syntax for loop is initialization, condition, increment or decrement. And here the code to be repeated. Initialization. It is a starting point. Like we just initialize like starting point. We have to initialize a number. So we just take it as 0. And next the condition. Here the condition is applied. Loop will run while this is true. The loop only run if the condition is true. Like we have to here I is lesser than 5. Increment or decrement. It update the value each time by increasing the I one by one. Now we just take one small example. Here we initializes the I is equals to 0 and we give the condition like I is lesser than 5 and we incremented like I it will be increased one by one. We just gave a print f and the output will get like here, the output we get as 1, 2, 3, 4. And the explanation for this output it starts from 0 and prints the number. It increases each time by 1 and stops. It stops when the I becomes 5.
And the second is while loop. While loop is used when you don't know exactly how many times you need to repeat. It depends on a condition. And the for syntax for this is while and the condition to be given and the code to be repeated. It first checks the condition. Next, if the condition is true, it runs the code. If it keeps running until the condition becomes false. Example, here initializing the I is equals to 0. While I is lesser than 5, it print by I incrementing the I by 1. The output we get it at like from 1 to 5. Here it takes here we initializing the I is equals to 0. So that the I takes the value it takes the value as 1. Here 1 is lesser than 5. So the one code is executed and next it goes to 2. Same. Your 2 is also it is lesser than 5. So the 2 is implemented and same. The 3 is also lesser than 5, so it is implemented. Next it goes for 4. Here the 4 is also it is lesser than 5, so the print. And when it comes to 5, here given the 5 is not lesser than 5, it is equal to 5 and the condition equal is not given, so it doesn't print. It stops till 4 and it print. Explanation for this is it start from the 0, it print increases I, checks the condition again, stops when I reaches 5. By using all the basics which we have learned here, now let's build a simple mini calculator using C. Let's start with the programming code. Why this program matters? Because this calculator allows us to perform a basic arithmetic operations like addition, subtraction, multiplication, division, and modulus. Here we are not using any advanced features like loops or switch statements, just plain if and else, which make it ideal for the beginners. Learn how to handle the C logics and input and output. So now let's begin with the program. Here we start with the main statement. It is the header file. This line includes that the standard input and output library. It allows us to use the functions like printf for output and scanf for input. This defines this int main, this function. This defines the starting point of the program. The main function, here the main function is the where the execution begins. Here the character operator. A character variable is stored the operator entered by the users. Example like addition, subtraction and multiplication, division and modulus. Here number int number 1 and number 2. Two integer variables to store the numbers the user will enter for the calculation. Now, next here the printf. Here it asks the user to input an operator. It's scanf. In the scanf, it takes one character as the input. Here the space before the modulus of C. It is important. It ignores the leftover space, white space like a new line from the previous input, ensuring the proper reading of the character. Okay. Now it has the input to enter two numbers. Here the scanf. Scanf stores the user's number into the number 1 and number 2. Now the conditional check using if statements. Okay. Here if operator is equals to plus, if the user is entered the plus, here it performs the addition and it prints the result. Next, if the user is entered the minus, it performs the subtraction and prints the result as the number 1 minus number 2. Else if here same if the operator is if the user is entered the multiplication, it performs the multiplication and prints the result. Same if the operator is division, it checks the whether number 2 is not 0 before the performing the division. If number 2 is 0,
it prints an error message since the division by 0 is undefined. So next here it goes to the modulus. If the operator is modulus, it does the same check as the division. Make sure the number 2 is not 0. If the here the modulus calculates the remainder of the number 1 divided by the number 2. Modulus is used in printf to print the single modulus because the modulus special format specifier in C. Next, if none of the operator is matched, the operator match the block runs and tells the user it blocks the runs and tells the user that the operator is the invalid operator. And here we end the program and the return 0 to the system, indicating the successful execution. Now let us run the program to see the what results. Here we run the program. We have to enter any one of the operators. Like let us enter the operator as plus. Here it asks us two number. So let us take it to number 12 and 16. Enter. The result it is finished as 28. So it takes the two number and the sum of the two number is 28. So now let us run again the program. Let us take like division. Let us input two number like 24 and 4. 24 and 4. We get it as a 6. The program finished with execution, so is 0. Next, let us do for another one. Let us take the modulus. We will enter a two number. We just enter like a 15 and 8. Here, the 15 divisible by 8 we get we get the remainder as a 7. See, the summary of the features are it takes the two integer inputs and a math operator. It performs a basic arithmetic operation using if else only. Handles the division and modulus by 0. It prints a clear error messages. So far, we have covered the basics of C programming, starting with a general introduction, how to run program, and important fundamental concepts like variables, operators, and control structures. To apply these concepts, we also looked at a mini calculator program, which helped us to understand how user input and decision making work in a real example. Now let's move forward. Now we are moving on to the next key concept in C is functions. Introduction about functions. A function in C is a block of code designed to perform a specific task. Functions are fundamental in programming because they allow us to break down the program into smaller, manageable pieces, making it easier to maintain and debug. In C, a function typically consists of function name, parameters, return type, and the function body. Function name, the identified by which the function is called. Next, parameters, input that the function may take. Return type, the type of the value the function will return. Example, int, float, and void. Function body, the code that get executed when the function is called. Next, function helps in reducing redundancy, modularizing the code, and improving the code reusability. They can be used to perform calculation, process data, or even handle the input output operation. Example, we have taken a small example like int addition, like addition in A in B and return A plus B. Here add. Add is a function that takes two integer arguments and returns their sum. Now let's move forward to the function declaration. The function declaration, also called as the function prototype, it tells the compiler about the function's name, return type, and the types of its parameter. It does not provide the function's body, that is, the code that defines the function's behavior. It just declares that the function exists and provides enough information for the compiler to recognize it when used. Syntax for return type, the function name, and the parameters to be written as parameter 1, like type 1 parameter and the parameter type 2. Here return type. Return type, it specifies the type of a value that the function return. Here same, the example is the int, float, and void. Function name, the name by which the function will be called. Next, parameters type, the type of the argument that the function accepts. Optional, it can be optional or depending on the function. And the second is the function definition. The function definition provides the actual implementation of the function. It specifies what the function will do and when called. It includes the function return type, name, parameter, and the code inside the function body. Syntax same. Return type, function name, parameter 1 and the parameter 2. Here the function body, the code to execute when the function is called. Perform the task, it compute values and return result. Example of the function definition. Int addition int A and int B, here return A plus B. Here the function adds the two integer and returns the sum. In this example, the add function takes two integer parameter like A and B and returns their sum. The function is now fully defined and can be used in the program. Example of now next we move to the function. Example of the function declaration is int add, int and int. In this example, the function add is declared to return an int and takes two int parameter. But the body of the function is not provided here, just the declaration. Here we have declared only the declaration. We have not provided any of the body. Okay. Next is the function calling. Third is the function calling. A function call is the act of invoking a function to perform its tasks. When you call a function, you provide values known as the arguments that corresponding to the parameters in the function definition. After performing its task, the function may return a value to the calling code. Syntax is the function name, argument 1 and the argument 2 so on. Function name, the name of the function that you are calling. Arguments, the actual values you to pass to the function. These values must match the types of the function parameters. Example of the function call. Here we took the result as the add is 5, 3. We calling the add function with 5 and 3 as the argument. Then we are printing the result. The result is printed as 8. Here the add is the function called with the two arguments 5 and 3. The function returns their sum, which is assigned to the variable result. Finally, the result is print using the printf. Now it is a complete program of those three functions, the declaration, definition, and the calling the function. Here we started with the main statement. Here the function declares int add int in, declaring a function that takes the two integer and returns their sum.
int main is the main function. Here we are calling the function as a is equals to a is equals to 5 and b is equals to 3. Here we are calling the add function with the argument ca and b. Add function we are calling that. We are printing the sum of the d and d here, a comma b is we are printing. The output we get the sum of the 5 and 3 is 8, and here we are returning the function. Here function definition int add int x comma int y, return x plus y. Here return the sum x and y. Types of function. In C programming, functions are essential part of structuring and organizing code. There are mainly two types of function. That is built-in function and user-defined function. Okay. Now built-in function. Built-in functions are the library function. They are the predefined functions in C that are provided by the C standard library. You don't have to write the logic for these functions. They are already defined and compiled. You only need to include the relevant header file and call the function. The key points in this are it already defined in the header files like stdio.h, stlib.h and mathfunction.h, etc. It's the development type. It tested and optimized for the performance. It cannot be modified. It cannot be modified by the user. We can calculate the square root of a number using a built-in function square root from the math library. Here we have include the math library for the square root. We have include the math library for the square and the mean, and here we choose the built-in function from the math to calculate the square root. Here we have used the double for the square root, and we have printed the result here. For this, the output we get it as a 4. The square root function takes a number typically as a double. It takes a number typically as a double as an argument and return it's the square root. In this example, the square root of the 16. The square root of the 16 is calculated and the result is printed. And the second is user-defined function. In C, user-defined functions are the function that are created by was written by the programmer to perform a specific task. These functions help to organize and modularize the code, especially for the large programs. Okay, here it is a structure of a user-defined function in C. The structure of the user-defined function in C. First is function declaration. It is known as a prototype, and the function definition. In function declaration, it tells the compiler about the function's name, return type, and the parameters. Like the function name is a int and the return type and the parameter, and here function definition. It contains the body of the function. Okay, here the example is add int a and b and return a plus b. Third is function call. It invokes the function to perform a task. Here we can add the two numbers and it stores the result in the variable result. Okay. Now let us take one example for this. We have took an example for us function declaration, function call, and function definition. Here in function declaration, this tell the compiler that the function name add exists, which takes the two int parameters and returns an int. In function definition, this is the actual implementation where the implementation of the addition function takes place. It takes the two integer a and b and it adds, and then the result is printed. In function call, in this main function, we call and add we add the number like a and b, and it stores the
a result in the variable and it will print the result. Advantages of the user-defined function. There are the four main advantages. They are code reusability, easy to debug and maintain, increase readability, reduces the code duplication. In code reusability, a user-defined function can be written only once and it can be used multiple times throughout the program. This avoids the rewriting of the same logic and makes the code more efficient. We just Next, easy to debug and maintain. Here, when the errors occurs, we only need to check the specific function, not the entire program. It makes it easier to fix bugs and update the logic in one place. Increases readability. Your functions makes the code cleaner and more organized. It gives the meaningful names to the function that help us to understand the purpose quickly. Reduces the code duplication. Here, we don't have to write the same block of code repeatedly. It reduces the file size and risk of inconsistent changes. Now, next move to the function parameters passing in C. In C, there are two types of pass parameter to a function. That is, pass by value. It is a default method, and pass by a reference stimulated using the pointers. First is pass by value. When you call a function, a copy of each argument's value is passed to the function. The function works with a copy, not the original. Next, the key characteristics. It is the original variables remain unchanged. It is the safe and simple default behavior in C. And here let us take a small example. Here the function that modifies the x. Here the changes takes inside the function. Okay. And here it passes by the value. It passes the copy of a, and here the a is unchanged. A remains changed and a is unchanged. In the main function, a is equals to 10. A is passed by the value of a change value in x. Inside the function x is set to 11. Okay, inside the function x is set to 11, but is just a copy, not the original. Therefore, 10 remains unchanged after the function call. Yes, same. The explanation is the value of a is copied into x. It changes to x and it does not affect a. And the second is pass by reference. It is using the pointers. Here, instead of passing a copy, you can pass the address of the variable. This allows the function to modify the original variable. The key characteristics are original variable can be modified. It requires a knowledge of pointers, simultaneous reference behavior. Example, here the function that modifies the value using the pointer. Here the change the value at the address point by x. Next, here it is incremented a and it is a pass by a reference using the address. Here a is modified. The output we get inside the function we get x as 11 and outside the function we get a as 11. Explanation for this is in a. Like a is equals to 10. Here, a variable a is declared and initialized with the value 10. And here the change of the value. Instead of passing the value of a, we pass its address using the AND a. Here, we passed using the AND a so that the function receives a pointer to a. In function definition, void change value. Int x int x is a pointer to an integer. X is equals to 11, like pointer x is equals to 11 means we are changing the value at the memory location pointed to by x. So this directly modifies the value of a. In this output we get as inside the function x becomes the 11, outside the function since a was modified through the pointer, it is also now 11. Okay, now same explanation is the address of A is passed to the function. The function dereferences the pointer and modifies the actual value stored at the memory location. Okay, now let's dive into the next topic is the function return type in C. Okay, a function return type in C. The function return type specifies the type of the value that the function returns to a caller after the execution. Yeah, every function has a return type. It specifies what type of the value will send back to the caller after it is execution. Then what is return type? The return type is declared before the function name. As it is declared before the function name. It tells the compiler what type of data the function will return. Next, the common return types include int for integers, float or double for the decimal numbers, and char for the characters, and void for no return value. Next, syntax for the function with a return type. Here the same, the return type and the function name involved in the parameters. Like the code, we have to return the code, and it requires here return value. It required for the type is not void. That is same. The return value is required if the type is not void. Next, we take an example of a different return types. Here int return types. Here int is a return type and the return type of the value is like it add, and next it returns the integer value, and here the float returns the floating point number. Here same, here floating point number, it divides it and it give the answer. Here character returns a single character. Here if the marks is greater than or equal to 90, it will return as A, else it will return as B. Here it return a character type void. Here when we use void, if a function doesn't return anything, it uses the does not return any value, it uses the void as the return type. Next we move on to the topic called as recursion in function. What is recursion? Yeah, recursion is a programming technique where a function call itself to solve a problem. It is useful for the task that can be broken down into a smaller, similar subprograms. A recursive function must have a base case to stop the recursion and a recursive case where the function continues calling itself. When to use recursion? When we have to use the recursion, when the problem can be broken into a similar and subproblems. In the data structures like trees and graphs, we can use the recursion. And for the elegant solution problems, like factorial, Fibonacci sequence, Tower of Hanoi, or the searching and the traversing trees. In these functions, we can use the recursions. Yeah. Now take one example for the recursion in a function. We just take a factorial. Factorial function. This factorial function calculates the factorial of the given number. Here, in the base case, when n is equal to 0, the factorial is defined as a 1. In the recursive case, the factorial of n is calculated as n into factorial of n minus 1, which breaks the problem down into a smaller subproblems. It recursively calculating the factorial of n minus 1 until the base case is reached. In the main function, we set a number is equal to 5, which means we want to calculate the number till 5. And the factorial of the number function is called, and the result is stored in the result. Finally, the result is printed as the factorial of 5. How it works? Let's go for a small step by step. How it works? Here, it takes the factorial of the first, the 5. Here we take the 5, it takes the factorial of 4. Next, for it the factorial 4 calls the function for 3. And next the 3 calls to, and the 3 calls to 2. Same, the 2 calls the function to 1. Here the 1 function's called to 0 and it is a base case. So the factorial 1 returns to 1 as a base case. Then the recursion and bits, here the factorial of the 1. Okay, 1 is 1 into, okay, 1 into 1 is equal to 1. Same, like 2 is equal to 1 into 2 is equal to 2. And 3. Next we take as a 3 into 2. 3 into 2 it is equal to 6. And same 4 into 6. 4 into 6 is equal to 24. Same, here we take as 5 into 24. 5 into 24, we get the result as 120. Thus the output is 120, which is the factorial of the 5 is all, which is the factorial of the 5. And the next topic is functions pointers in C. What is the function pointer? A function pointer in C is a pointer that points to a function instead of a data value. It allows you to call the function indirectly, pass the function as arguments, and create arrays of the function. And the basic syntax is a return type and the pointer name, and the parameter types. Okay, let us take a small example code. Small example code function pointer with a void greet. We have to create the void greet. Here, void greet is a function that does not takes any argument, and here it returns nothing. It simply print a message. Here the print message which we have given like hello from a function pointer. Here the function point declaration. Same here the declaration. It declares a pointer to a function that returns void and takes the no arguments. And we are here assessing the function. We are assessing the function address of the function. It assesses the address of the greet to a function pointer. Here we can also write the function pointer is equals to and greet. And here we are calling the function. It invokes the greet function through the pointer. And here output we get as hello from the function pointer. Next, we learn about the topic called as a function pointers with parameters. What is a function pointer? A function pointer can point to a function that takes parameters. The syntax must match the function's signature. Here we take one small example as addition and subtraction. Here, same. We started with the standard input output library, so we can use the printf for the printing output, and int add and int a and b. A simple function that returns the sum of the a and b. Here, same. In subtraction, here the same. It returns the difference between the a and b. Void compute. Here we have used this operation. This is a key operation x and y. Here the function pointer. It is a function pointer. This pointer can point to any function that takes the two integer and returns an integer. Inside this function, it calls the function that pointers point. It calls the function that pointers point to that the result is printed using the printf. And the next is the main function. Here the main function, here the way the execution begins. Compute. We call the compute and the passes the x as 10 as x and 5 as y. Here the add function is the operator. Same, we have passed the add function as the operator, and inside it compute. This becomes and result add the 10 plus y and we give the result as a 15. And next compute for the subtraction. It's same as the above, but they uses the subtraction function. it uses the subtract function. This becomes the result as subtract 10 into 5. It takes the result and become the 5. Same. Here the computer takes a function pointer as a parameter and calls it with a two integer. This is a simple example of it. This is a simple example of a callback function. So, okay. Now let's conclude our topics. Yeah, what we have learned today are we have learned about the functions. What are the basics of a function? Like function are the fundamental building blocks in the C programming language. They help to break the complex program into a manageable pieces, making code easier to write, understand, and maintain. In this exploration, yeah, we have covered the topics as function declaration, definition, and calling, and the types of function in that is user built-in function and the user-defined function, and the parameter passing what by value it passes by the value and the by reference, same returning the values from the function, recursion and its importance, function pointers, and they're used in the advanced programming, passing the function as the argument using the function pointers. With that, we have come to the end of this presentation. I have covered the basics of C programming, demonstrated a mini calculator program, and explained the concepts of function. These topics are essential building block for writing efficient and organized code in C. Thank you for watching and taking the time to go through my assignment presentation. I hope it was clear and informative.